Okay, so on packet 8, number 1, the population of deer on an island is given blah, blah, blah. X represents the number of years. So remember, whenever I write these, and it says P of X, because it's talking about population. Remember, I can put any variable there in front of that X, right? Okay? So 100 times 0.85 to the power of X. Remember, this power, when I talk about growth and decay, is always talking about time. Okay? Determine the percentage rate of change for the population of deer. So let me ask you something. If this is a 0.85, is this a growth or is that a decay? It is a decay. Very good. If it has a 1 in front, that means I added, which would be a growth. So this is a decay. Now, what is the percent of decrease? Percent. Can I have a decimal in percent? So how do I find that? What do I always start with? What percentage do I always start with? How much of the population? 100% of it. All of it, right? Always start with 100% of our population. Decreasing. Subtract that. What do I get? 15%. Remember, you either have a percent symbol or you have a decimal. You're not going to have both. Okay? So, if it's decreasing, how much by? I always start with 100% of my population, subtract that to get what's missing. Okay? Okay, let's look at number 2 here. Kim purchases a car for blah blah. She's given a table showing the data representing the expected depreciation. If it is a depreciation, is that a growth or a decay? That's a decay or a decrease. Remember, those things are synonymous. Growth, increase, decay, decrease. Okay? So, as I look at the table, what percent of depreciation is used? How am I going to find that out? Remember, it's a rate of change. Okay? So, we're going to take 24,570 and divide it by 27,000. Okay? And we get 0.91. Right? Second term minus the first term, right? For a common difference. Second term divided by the first term to get that common ratio. Okay? So then we would put that into our formula, which is, since they didn't give me one, I'm going to use y equals. I could use f of x, right? Same thing. What did I start with? What I started with is 27,000, correct? And I already found 0.91, and then there's my time. What you started with, 100% of, so we already did this, okay? So now, how much is it decreasing by? Subtract all of it minus what? 91. And what do we get? So about 9%. Okay? This is just a reminder of how we work the equation. What I start with times my decimal, okay, raised to the amount of time. Okay? So let's look at number 4 on the back. This should touch on another one. Select all expressions equivalent or equal to. Equivalent means equal to. So 27 times 3 to the n minus 1. This is y equals. It doesn't say that, but it is y equals. So I would put this is what I would do. I'd put this in y sub what in my calculator. And if I want to find what's equal to it, then I would put the next ones in y sub 2 and see if they're equal. And then y sub 1 and y sub 2 and compare them. So you're going to compare them in the calculator. Okay? So this is what I need you to write down, this right here. Write down what I'm writing down. Okay? And check the table. Just like we did the other day. To see which ones are equal. And you'll be able to find those. Okay? Now, the next part is more practice of what we have just done. You will type those in, and tomorrow when you come in, if you want to type those into your calculator for a few minutes just to make sure, then you can do that. But you would just type this one in just like it is, except in the calculator, right, we have to use X there, right? And then you would type in that answer choice, 3 to the 3n minus 3, and then C, check the table for exact values. Okay? So that's just a reminder of how we work growth and decay. Okay?